Okay, so carrying on here. So yeah, as a reminder, yesterday we looked at graphs that went through 0, 0, but also ones that didn't do that anymore, and they called those partial linear relations. They're partial linear relations because they're not going through this 0, 0 point. But overall, we've dealt with just straight lines. That's all we've dealt with so far, and specifically, we've dealt with straight lines that are a positive slope. So those of you who were here last block, how do I know that this is a positive slope here, this line?
Because
It goes up, right? You read it like a book from left to right. You start with the left, it's going up, it's a positive slope. What we're going to be dealing with now is we're going to be dealing with stuff with negative slopes. So if a graph is negative, so if it goes down as you read it from left to right, like a book, then that means it has a negative slope. So you could have a graph, you don't need to draw this, you know, it could look something like this. You know, it could look something like this as well, where it goes through 0, 0. It doesn't have to, but basically you're going to start having graphs now that are going down as we go from left to the right. So there's an example here, just to give you an idea. So in this example, there's a car, and so she's filled it up, right? When you fill up your car with gas and then you start driving, the amount of fuel in your car goes down as you drive more, right? And so they wanted them to make a table with this information. So this is their information here, and then they wanted to graph that. So like how far they drive versus how much fuel is left in their tank. So obviously, the more they drive, the more fuel gets used, the less they have in their tank. That's what ends up happening here. And so what that looks like in a graph is this. So as we go from the left to the right, we can see that it goes down. So when you've driven 0 kilometers, they had 40 liters of fuel in their tank, and then it just slowly and slowly goes down over time. So that's an example there of a negative slope. So we're going to work on one of those really, really quickly. But where how you know a slope's going to be negative when you don't have a graph is it's going to have a little negative thing right there. So you see how there's a negative 1/9 here, and how they got that negative was, okay, it's 30 minus 40. They got negative 10/90. The second you throw one of those things as negative, you know the entire slope itself is going to be negative. So that means this slope for sure is going down. So remember, this is rise and run, right? But just because it's rise doesn't mean it has to go up. In this case, it's going down. So it goes down 1 for every 9 that it goes across, is basically what's happening there. Oops. There we go. So we're gonna go straight into making one here, right here. Question 10 on page 24. So on page 24 here, what we have is we have a 500-liter water tank that's leaking at a rate of 10 liters every 3 hours. So giant water tank has a hole in it, it's leaking water. So as time goes on, it's going to be less water in it. So if we want to graph this data, it wants us to make a table of values. This is the fancy way of saying it wants us to make a T-chart. And so when you make yourself a T-chart here, what we're really measuring here is we're just trying to get some plots here, right? We're trying to get some points to put on a graph, because we need points to make the graph. And so does anyone have any guesses as to what 2 things we would put up here based on the information up top? The which one? Liters, yeah. And what's the second one that you think? Sorry? Yeah, time. Yeah, absolutely. So yeah, those are the 2 things that we would put up there. So that's for the most part the same book that we got. I've just added on to it. So you have some of the stuff from there from yesterday, but there's a whole bunch of new stuff as well. So yeah, we have liters and we have time. And so whenever we start a T graph, first off, it's telling us what it wants us to put in there. There's also another one that we put. we always put 0. How many liters do we have when nothing's happened, no time's passed? How many liters are in that tank? 500, right? And then it wants us to put 3, 9, 15, and 24. So I'll put that. So 3, 9, 15, and 24. Whenever you make one of these charts, you usually just want to put like just 4 or 5 things is usually more than enough. Okay. So cool. So what's happening as time goes on? What's happening to the water? Yeah, it's going down. Yeah, I saw that. I saw that happen. So it's going down. Specifically, every 3 hours, it goes down 10 liters. So how many liters would it go down after 3 hours? 10, right? So now I'd be left with 490 here. And then over here for the time, so we get to 9 hours. How many liters have I lost over 9 hours? 30, right? Because it's every 3 hours, I lose 10. So this is just 3 threes, right? So I've lost 30 liters here, which means I'm at 470. I take that 500, subtract that 30. That's where I get 470 from. After 15 hours, again, that's just 3 times 5 there, right? So it's 5 tens. I've lost 50 liters, so I'm at 450. And then eventually I go down to 420. Cool. So I've created my table of values. Now all I need to do is I need to graph this. I need to get the scaling right. But before I can do that, I need to figure out what goes where. What goes on the x-axis, what goes on the y-axis. So which one's the x-axis? Is it the one that goes up and down, or is it the one that goes to the left and right? Sorry? Oh, so the x one goes to the left and right. So that's this thing here. And the y is the one that goes up and down. So I need to figure out which one goes where though. So remember we dealt with those independent and those dependent variables. And that independent thing is that's something that you can select as much of it as you want. Whereas the dependent variable is dependent on other stuff. How much money you make is dependent on your salary and how many hours you work. But when you're making a graph of your salary, you can say, yeah, you work 10 hours, you work 20 hours, you worked 0 hours. So in that case, the time is the independent one and the money you earned was the dependent. What would it be in this case, you think? Which one would be my independent one? Yeah, time. Time is going to be independent. Good rule of thumb is time is almost always going to go on the bottom on your x-axis. Specifically, it's time in hours. And then on this left side here, well, that means the other one here has to be our dependent. So this is our x, and then these are our y's. So this one over here is liters. Cool. So now I need to figure out my scaling. Now, how could I figure out how much each one of these lines is worth? Let's look at the time one. How many hours does this graph have to go up? At least 24. And I know there's 15 things here. So if I take that 24, I know it needs to go up 24 hours. I know I only have 15 squares available. So it's 1.6. The biggest closest number there is nice and clean is 2. So each one of these lines goes up is 2. So this is 2, then 4, then 6, then 8, 10, 12. Oh, sorry. Yeah, 4. No, whoops. 4, 8. I'm just skipping the second one each time. 12, 16, 20, and then 24. Perfect. I've met that. You could also go up by 3s if you wanted. Just because like, hey, everything here goes up by 3, but like there's no real wrong answer there. Just pick a nice, easy, clean number that you know will fit, and you're good to go. Now, same thing for my scaling with my amount of liters though. I know I need to use 500 liters here, and I only have 15 squares to do it. So I know each one of those squares needs to be at least this big. So what's an easy number we could probably get from that? It has to be bigger than that. We could do 35. Might be a little, yeah, maybe we'll try 50s. Like 35 would work, Austin, just so you know, 35 would work. I don't want to have to think about like where like 420 would be like on a 35 scale. So I'm just going to pick nice, easy 50s. But again, 35 would work there, Austin. You get full marks for that if you did that. And 500. So if you go up by 50s, in this case, I went up by 100 just to save myself some space. You should get something that looks like this. So then what's my last step I need to do here then? Just graph it, yeah. So I know that for my x here, when it's at 0, that's right here. I know when my x is 0, my y is 500. So I go up to the 500 when it's at 0 here. Boom. Same thing when my x is 3, which is about right here. I know that it goes up to 490. Now, it doesn't tell me where 490 is, so I'm just going to do my best guess. It's not going to be perfect. That's okay. And same thing. It's when my x is 9, which is about right here. My liters are 470. There's no 470 on there. So again, you're just doing your very best guess. So eventually, once you've done that, if you connect these points here, go from point to point to point, you're going to find that you get for you, it should be a straight line. For me, it's just a curvy nightmare. Yeah, eventually you should have a graph that looks like this. I will give you just a moment. So you should get a graph that kind of looks like this. So what you want to do is you want to actually now, just before I even go into that. So just for the scaling here, I went up by 1 day for every 2 lines. And I went up where each line is worth 25. So when, 25, 50, 75, 100, so on and so forth. If you did it slightly different, that's okay, as long as it's consistent, right? Because you want to make sure that every line you go up is the exact same. But so what I've done, what I now need to do is I need to graph this line. That's what I need to do. So I need to actually take this and I need to just connect each point here as I go in. So I know on the 0th day, I've sold 0 orange juices, and I just go from line to line to line, one at a time. So before we just did one nice smooth thing. Now you're just going to go from one line to the next line, to the next line, to the next line, to the next line. You want to do it with a ruler if you can. So I'll give you a couple of seconds to do that. Just connect all the points on your line. Go from just point to point to point. So when you have your line there, does that look like a straight line? Don't look at mine, look at yours. Does your line look like a straight line? It kind of does, right? It does look like a straight line. And so what when we check to see if does our graph appear to be linear? Yes, it does appear to be linear, but we don't know for sure. From now on, we're never going to know for absolute certain. And so when it means that it's linear, that means that the distance between 2 points on the graph is always going to go up. It's always going to have the same rise and the same run. It's going to have the same slope for every single point. If it's off by even a decimal, it doesn't have the same slope. It's a not linear graph. So let's give this a test out. So how we can figure this out is we just calculate the slope for 2 sections of the graph. So what that means is, just as an example, let's say like section 1 here, I want to figure out the distance between these 2 points. And then section 2, I want to figure out maybe the distance between these 2 points. That's what that's asking you to do. And so if this line is the same for both of them, has the same slope, you know that the entire graph is straight. That's what it's asking you to do when it says calculate the slope for 2 sections of the graph. So if it's asking you to prove that it's a straight line, that's what you're doing. You're taking 2 sections, you're making sure the slope's the same. And you can do that with that m is equal to y2 minus y1 all over x2 minus x1. That's how you do that. And you're going to be doing that twice. And to give you an idea what that should look like, that should look something like this, where side by side, we have the same formula. They just took 2 different sections of their graph up here, and they saw that, oh, the slope is different, which means it's not a linear graph. So this is what it should look like for you. So instead of me just doing it, I want the same thing. I'm going to give you guys some time to do that, but I want you to use these 2 points as a section. And then I want you to use these 2 points as a section, just so we're all using the same stuff. So this is going to be your first section. This is going to be your second section. If you're not sure like how to do it, just try it in pencil. It's okay if you don't get it right. That's the whole point of this. We're just giving it some practice. So try to calculate the slope of these 2 different things. And again, as a reference, this is about what it should look like, just with different numbers. Pause the recording. Okay, so as a reminder, so what we did was we were taking a look at these 2 sections of our line. So those 2 green sections that you can see right there, and we're checking to make sure those have the same slope. So if those have the same slope, we have a straight line. If those slopes are different, it's not a straight line. So I've done the calculations here, but basically I took that y2, y1. If you're not sure how to find that, we can work on that during the break or later today. But I took my points from my first section, so these 2 points. I calculated the slope between these 2 lines, and I can see that the slope of this section here is 52 over 1. It's 52. So it goes up 52 for every 1 it goes across. And then I took the second slope, the one right here, and I found that that one was 54 over 1. So our slope's the same or different? It's different. So what does that mean about it? It's not a linear line. It looks like a linear line, but it's actually not. So does the graph appear to be linear? Yes. Is it actually linear? No. It is not a linear line because our 2 slopes are very slightly different. So what that means is this person was selling more orange juice as they went later into the week than when they first started. Okay. So I'll give you a second just to get that in there. You did that different points in those? 1 and 2 and 4. That works. That works. You can do that too. I just picked these points just because I just picked them. You could have picked any combination there. Oh, 52, 50. Yeah, that sounds about right, actually. And then this one went up by Oh, no, this one went down. Interesting. Okay, everyone have that in? No one is saying no. So for those of you from last block, this is going to be a blast from the past. From those of you who are new, we're going to do a little bit of accelerated learning here. We don't need to understand this, but basically there's a formula to calculate the area of a circle. So this is really helpful, by the way, if you ever want to like figure out the best bang for your buck when you order from a pizza place, but that's beside the point right now. What we want to do is we want to draw a graph of the radius of the circle, of the area of the circle, and then check to see if the relationship is, they call it linear, which means is it a straight line? So how we calculate this one out here. So it's A is equal to pi. This R here is the radius squared. So how you can put that in your calculator, don't worry if you don't get it. This took us a couple days last block, is if I want to figure out the radius is 2, I would take my, you have a pi button right here. So it's going to look something like this. You should have this type of a button right here on the top right corner. So if you take that pi, you times that by, it's the radius squared, which means it's 2 squared. 2, you press this little x2 button, or you can just do 2 times 2, because that's what 2 squared is. You get yourself an answer, which is 4 pi. We don't care what that is. I want to turn that into a decimal. I can see in this case, the answer is 12.5 blah, blah, blah. Right now, I don't care about the decimals. I'm just going to say the area of my circle when my radius is 2 is 12. That's all I'm going to say. I'm going to give you just 30 seconds to try and calculate these out. If you don't get it, that's okay. That's not the point we're trying to do today, but I want you just to fill in this table of values using this formula here, where you just, instead of R, you put 3 and then 8 and then 12. And just put the whole number. Just keep it simple. So 30 seconds, just quickly fill in that table. Because it's not the main point. So if you calculate this out, it shouldn't end up being these figures. I'm ignoring the decimal points for now, just because it's a graph, but it should get 12. Let me type that in, actually. So I get 12, 28, 201, 452. So those are my 4. Those are my 4 areas there that I get. Again, the main point today is not to figure out how to calculate the area of a circle. So what I need to do now is I need to graph this point. So before I even go there, do you think this graph is going to be linear just based off this? Just a guess. Do you think no? So sorry. Well, there's an odd number. So we're thinking maybe no. So let's find out. So let's really quickly give that a graph here. I want you to give that a quick graph here. So remember, figure out your scaling. You know that my independent thing here. Aiden, what's your guess? Which one's the independent? The radius. You think the radius? Yeah, because you can pick that whatever you want, which means so this is my independent, which means this is going to be on my which axis? X-axis, which means this is my dependent. So this is on my y-axis. So that means you're going to have radius on your x, and then area on your y-axis. So I'll give you 2 minutes there just to quickly try and graph that. If you need help, let me know, because I'm not circulating this time otherwise. Oh, I need to do attendance. So if you've graphed your thing, it should look something like this. So you can see my graph here. Now my graph, I just did scaling where each x-axis went up 1, and then each y-axis went up 50. You didn't need to do it exactly that way. That's okay. That's just what I chose. So what's my next step here I need to do? Sorry? Yeah, connect the dots. That's it. So I'm just going to connect my dots. So start with 0, 0. Connect your dots. And so if you've done that, is that graph linear? No. Why isn't it linear? It curves, yeah, yeah. Like technically this graph, it looks something like this, right? It's a curve. So yeah, in this case, it is a non-linear graph. It's not a straight line. It's a curved line, so it cannot be straight. So what we're going to do here for the next little bit, up until the break, is just some time to practice some of this stuff here. Yep. Oh, yes, I can. Like, quickly. You betcha. So yeah, your next little bit here is just some time to practice the skills. Once we get to the break, we're going to move on to the first part of 1.2, which is the equation of a line. So you have the next 30 minutes just to work on some of this stuff, practice that skill. And then we will continue on with the equation here in a bit. So you got half an hour here. If you need help, please let me know. Happy to come by and be of some assistance. So I could put any line on a simulator and I would get one. So let's say, for example, I'll show you what this means in a second, but let's say I have something like this. Actually, let's go like this. I have a straight line, and so I can figure out what every point on this line is. It doesn't matter how much I zoom in. I can figure out exactly what the x of something is and what the y of a point is on a line. Doesn't matter how far in I zoom or how far out I go and pick any line. There's always going to be something there. I can always figure out what that line is. And you can change what a line looks like by changing what the slope of it is. As the slope gets smaller and smaller, so I went from a 2, so it goes up 2 for every 1 it goes across. If I change that to a half, now it's going up 1 for every 2 it goes across. Or if I change that to a 10th, 1 over 10, you can see now it's basically like, it's pretty much like a flat line, right? I'll give you a chance probably tomorrow to explore this stuff in a bit. But for now, I just want to go into what the equation of a line is. We'll properly explore it tomorrow. But here we go. So this is on page 32 here. So we know that we can find the slope of a line using this formula here. So we can find the slope of a line using this formula here. But if you want to find the equation of a line, where if I tell you this is the equation, you can take an infinite amount of points and you can create exactly what that line should look like. You use this thing here. This is something called y equals mx. And so does anyone want to take a guess like what the y is? It's not something new. Same thing. Y is just the rise and the run, right? The y-axis is the stuff that goes up and down. So when we're talking about y here, this is nothing new. The y is still just your rise. And what is the m equal to? Yeah, m is the slope. And then the x is just going to be our run. So this is nothing new here. It just kind of comes together into a different thing. So we'll help you show what this means in a second here. But for now, you just want to like either highlight this, circle it, square it, put a star beside it, something. So
So we can use this formula here to calculate a bunch of different things. So let's say, for example, I know what a point is. If I know what a point is on a line, let's say, for example, let me just erase this. If I know, let's imagine this is, 1, 2, 3, 4, and then 1, 2, 3. If I have this point here, I have so x is 2 and this is 1. I could use this line, this formula, to figure out the slope. So if I know what a point is, I can figure out the slope. If I know the slope, and I know that, hey, at some point your line's going to pass through 4 on your x-axis, I can figure out where it's going to go through on here with that formula. So you can figure out the y value if you know an x. So if I know an x, I can figure out a y. If I know a y, I can figure out an x, and so on and so forth. Again, I'll show this to you in practice. It's okay if you don't get what I'm saying there. That's okay. So there's an example here where they took a formula which is y equals 5x, which basically is we can take any y, we can take any x, and we have a slope of 5. So if they make a table of values here, a t-chart, and all they did was they just picked random things. Like, so let's say, for example, if I have this formula, what they did here was they figured out that, oh, okay, so what if your x is -2? All they did was substitute that in. So they just think, oh, well, it's 5 times -2. That gave them -10. So when x is a -2 on their chart, their y was a -10. When x was a 2 on their chart, something like this, their y was also a 2. Again, I'll show you what that means in a second, but that's how they figured this out. So they just took any point and they were able to basically fill in the blanks. As long as you know everything in an equation except one single thing, you can always find what's missing. Let me just erase that. There we go. So this is what they ended up coming up with. All they did was they just figured out that, well, what is the, what's the y going to be when our x is 0? What's the y going to be when our x is 1? What's the y going to be when our x is 2? And so forth. They just kept going up and up like that. And that's what they were able to use that equation for, was to make one. So we're going to give that a little bit of a practice shot here. So we're going to try and draw that. We're going to try now draw a graph based on just an equation and nothing else. So how we do that is we're going to calculate the values of y. We're going to figure out what the y is when we have an x. So what that means is, let's quickly draw this in. So I'm just going to say, I'm going to go 1, 2, 3. Yeah. So let's imagine this one here is 0. Let's go 1, 2, 3. Let's imagine this is 1, 2. I'm just spacing it out a little bit. Again, the scale is not too important here. All I'm doing is I'm just spreading it out a little bit so that I have a pretty big graph, so it's easier to see stuff. So let's imagine this is 1, 2, 3, 4, and 5. Okay. So all we need to do is we need to substitute this in here. So what's actually happening here is if it says that x is equal to -2, it's saying what is this going to be? So if I put an x at a -2, what is the y going to be? So they take this formula, this -4x. Now what's between these two things? It's invisible. Any guesses? So when I say it's -4 and x, there's a little secret multiplication sign in there. I'm taking -4 and I'm timesing it by whatever I'm saying my x value is going to be. So I'm saying that if I'm saying x is -2, I'm going to take that -4, I'm going to times that by -2. That's what that ends up being. So that means I'm taking -4. Oops. Taking -4, times it by -2. Your answer is 8 in this case. So it's saying that when your x is -2, your y is 8. So all we're doing is we're substituting that into our equation instead of this x here. We're changing what we think that's supposed to be, and then that's going to tell us what our answer is going to be. So if I do this, so -4 times -1, I'm going to get 4. If I get, so 0 here, so if I get 0, it's just going to be 0. If I have a y is equal to 1, this is -4 times 1, it's -4, and then -8. This is what it ends up being here. You know what, actually. Yeah, this isn't gonna. Okay, this isn't gonna work actually. I put the wrong thing in here. What we're actually going to do, it's not gonna work, is it? This is negatives in here. Has anyone written in the right column like this in this little red white space? Has anyone written anything there?
No.
Has anyone written anything like on this part on your page? Okay, don't write anything else. If you do have an eraser, erase it. If you did, I'm sorry. I've realized what I put here isn't gonna work because this isn't a negative graph here. So what we're instead gonna do is we're going to make our own little table. So I'm gonna get us to actually make our own little table here. You're gonna look something like this. If you wrote something there, just put something below it. This is gonna be our X, this is gonna be our Y. We're gonna use the formula y is equal to, I don't know. Yeah, y is equal to 2x. Let's do that. Yeah, we'll do that. Perfect. Okay, so you want to make a little t-chart here, and then above it, you just want to put y is equal to 2x on the on top of that. So this we're going to ignore these two things. So just pretend they don't exist. And we're going to make a t-chart of it, and we're just going to use the first few numbers. So 0, 1, 2, 3, and 4. Sure, let's do that. So it's 0, 1, 2, 3, and 4. And so what I need to now do is I need to substitute instead of an x here. So instead of this being 2 times x, it's going to be 2 times whatever's here. So if I did this first one, instead of an x, it's going to be 2 times, there's a 0 here. 2 times 0 is 0. And same thing over here. So what would I get when x is 1? What would my y be? 2. And then when my x is 2, this is just 2 times 2, so it's 4. When my x is 3, it is 2 times 3, my x is 6, and then it goes to 8, and so on and so forth. I only need a couple of different points. I don't need a lot. I only really need like 3 or 4. And you can use that. That's usually almost always enough where you can just keep working on your graph, where you can draw the whole thing. So what we're going to do is we're just going to quickly plot this. When my x is 0, my y is 0. When my x is 1, my y is 2. When my x is 2, my y is 4. Now, when my x is 3, my y is 6. I didn't actually like put that in there, but that's okay. I'll just put it right there, and then that's it. So if I were to keep going, you know, eventually I'd get like up here and up here. I don't need to do that though. But what I have now is I now have an entire line. So using that equation, I was able to make a line, and the formula of this equation is, the formula of this line is y equals 2x. That's the whole thing here. So if I put y equals 2x, I'll give you a second. I'll come back to this. So if I put y equals 2x right here, I can see that this is the line that we just made. right here. So this is the line that we had just made here. So when my X is 1, when my X is 1, I can see that my Y is 2. When my X is 2, I can see my Y is 4, and so on and so forth. You could stretch this line out forever. So right now it's at like 18, for example. So we can use an equation of a line to make a line that goes on forever. We'll always know every single point on that line. Is everyone done with that part of it? No one's saying no. I'm going to start scrolling down. So yeah, this y equals mx. That is the formula that you're able to use for these three things here. So you just want to make sure that this is on page 32. We just want to make sure that you've like highlighted this somehow, whether it's drawing a star, underlining it, boxing it, highlighting it, doesn't matter. But just make sure that this equation and these three things stand out, because this is when you use this equation there. So if I scroll on down now, again, there's another example here. I don't really care too much about that. I'm going to use this one here. So this is going to be a graph showing inches to centimeters, right? So when you have a ruler, so when you have yourself a ruler here, you know, on one side you have inches, other side you have centimeters. When you have 1 inch, that's the same thing as 2.54 centimeters. The exact same distance, just different units. So this is a graph that kind of shows that relationship, is what they would call that. And so what you're going to do is, I'm up here, I'm just going to write my steps for it. Your first step, if you're ever unsure what to do, so right now it just says, here's something, graph it. Okay, well, how do I do that? Your first step is you're going to make a T-chart. So you're going to make a T-chart. I'll do, which is this little thing right here. Give yourself a little bit of space if you're going to do it to the right, and make yourself a T-chart. So give yourself some space. So that's this thing here. So what's going to go in this T-chart? Well, you have your X and you have your Y. So step 2 is going to be, I usually recommend just do this. -2, -1, 0, 1, and 2. We'll get into those negatives in a bit. We don't need to worry too much about those. But when I say -2, -1, 0, 1, and 2, that means you're going to put those in your T-chart. If you do those 5 things, this is almost always going to be enough for pretty much every graph you're ever going to deal with. So I'm just going to say, well, what happens, you know, so what this is saying here is, let's imagine this. Okay, so when my X is 1, eventually it's going to tell me what my Y is here. One thing I already know, though, is that this is going to be about inches and centimeters. So I already know that when I have 1, let's imagine that this is our inches down here. And then on the top left, let's imagine that's our centimeters. We don't have an independent or a dependent relationship in this case, so you can just do whatever you want. But I already know that when I have 1 centimeter, or when I have 1 inch, that's my X, I have 2.54 centimeters, because it tells me that. So for every 1 inch I go up, I get 2.5 centimeters, which means this is just going to be that 2 times 2.54. This one over here is just going to be 5.08. I know that if I have 0 inches, I'm going to have 0 centimeters. We'll come into these negatives in a bit. We'll probably back up here in a day or two. But eventually I'm going to be able to graph this thing out. So I'm going to be able to graph this out. So I'm going to really quickly just draw my graph. Not going to be super precise. I'm just going to go up by like 2s and 3s. Sure, we'll make you 4, 8. and 12. I'm not caring too much about being like super precise, but I know when I get 1 inch, I get about 2.54 centimeters. When I get 2 inches, I have about 5 inches. And same thing, if I had 3, I'd get, so this is 2.54 times 3, I'd get 7.62 inches. So all I've done now is I've just plotted my graph. I can really, really quickly just draw a straight line, and I want to extend the line now. So drawing the line's nothing new to us. But what we're going to figure out now is we're going to figure out our slope so we can figure out an equation with this. So I'll leave that on there for a couple seconds. I'm just going to quickly scroll on down. Which is how can we figure out the slope of this graph? Well, we do know that we can use that, m equals y2 minus y1 over x2 minus x1. In this specific case, though, where was it? We can just do rise over run. So again, there's an example here where because we know this is a straight line, we know this is going to be a straight line, I can just literally just do rise over run. So I know that it rises up 2.54 for every 1 it runs. So boom, there's my slope. So your slope here should just be 2.54 over 1. Or just 2.54. This is the exact same thing. This is on page 36. So the third question it's asking you here is, it now wants you to write an equation. So it's writing an equation about this graph. So the second you know you need to do an equation and a graph, you know you need to go to this thing here, y equals mx. So I'm going to really quickly write that in. So y equals mx. So just like yesterday, you're going to follow those same steps. Whereas I found my formula. Now I'm going to substitute stuff in. In this specific case, whenever you have this, all you need in a formula is just leave your y as is and substitute your slope. We know what our slope is. It's 2.54 over 1, and then x. All of a sudden, I now have an equation. That's the equation of the line we just made. Is y is equal to 2.54 x, and that's it. So I'll come back to this in a second, but same thing. If I were to take that, y equals 2.54 x. This is the equation that it makes here. Now I have a question for you though. What happens if I get rid of this over 1? What do you think is going to happen here? If I get rid of that over 1, what's going to happen to our line? So instead of y equals 2.54 over 1 x, it's just y equals 2.54 x. What's our predictions? It's okay to guess. I'll just quickly put it in here. So y equals, so if I put 3x, you see how the purple one's different there? So if I put y equals 2.54x, oops, it's the exact same line. So this over 1 here doesn't actually matter. Like it's just an invisible thing we put. So just so you're aware. I like to keep it as a fraction. You don't have to, but so this is our formula now with that line. So if I want to use this formula and I don't want to draw a graph, that extends up to 18 inches, I can then just quickly substitute this in. So if I want to figure out how many centimeters are equal to 18 inches using this formula, all I need to do is substitute that 18 inches in. Now, is the y or the x
What we use for inches in our graph.
Which one do we use for inches? X. So now what I know is I'm just substituting in what I know now. So I'm trying to figure out y, which is how many centimeters is equal to. So I'm going to put my formula in there, 2.54. And then it's going to be x. Now remember, there's a little secret invisible times there. So this is 2.54 times our x, which we're now saying is 18 inches. So how many centimeters will our 18 inches be? That's what this is. And the answer here is just going to be, all of a sudden,
That's pretty easy to figure out, right?
it's just 2.54 times 18. If I do that, I should get an answer of 45.72. So 18 inches is equal to 45.72 centimeters.
So does that make sense how I've used that formula? So once I have an equation, all I need to do is substitute what I do know to figure out
What I don't know. I didn't know how many centimeters there was, but I did know that I had 18 inches.
so I could use that to figure that out.
It's just exactly what you did way up here, just with a little bit of a different equation. That's exactly what you did there. So for the next, we only have 15 minutes here. So for the next 15 minutes, I just want you to try and do this next question that you had. And I think that was it. Yeah, so for the next 15 minutes, I just want you to work on that next question. And then if you finished these next two questions, there's two questions there. And that's it. So that's what you get to do for the next couple of minutes. We will be moving on and working a little bit more with this equation tomorrow. But for now, I'll stop talking. I'm sure you're sick of my voice, and I'll let you work on question 3 and question 4 for the next little bit here.